make it a little bit bigger. You might have a small screen. See it now?
Sorry, I'm muted. Yes, I see it. And that is one of the ones, yes.
That is one of the ones, okay.
Yes.
So what we're looking at here is a thing called a time series. So this is kind of doing the lesson slightly out of order, but it doesn't matter. What a time series does is basically you have two rows of information, and the top one is time. In this case, it happens to be the age of children, you know, 6 months old, 10 years old, and what the average height would be. We're being asked to take this data and put it onto this diagram underneath. And when we do that, we create what's, why did I do that? I've lost the darn thing. There we are. It can be a real pain. There we go. We're being asked to take this data and create a time series. So let me show you what you do. At half a year, the child is 26 years old. So this little guy here, you click on it and you pick the 2 dot one. And at 0.5, it's a strange diagram, it's about here, and 26 is about here. So I'm going to make a dot, and then I'm going to join it to 129. So 129, I'm going to put a second dot there. And what I've done, or what I've tried to do, is I've plotted the first 2 points from the table. So you can think of them as like coordinates, a half, comma 26 and 1, comma 29. The problem is that it's not very accurate. So if you go over here and you see this thing called graph layers, if you click on this, it will actually give you the coordinates of where those points really are. Now, do you see how the first point is actually at 27? So if I rub that out and make it 26, it's now in the right place. And you see how the next one is at 130 and it should have been at 129? I can do that. So I now have our first one fixed. Now go back, it's a little bit time consuming. Start at that guy and then go to 233. So 233 is about here. I'll go in here and fix the point. So 1, comma 29 being joined to 2, comma 33. Okay, I got that one right. Then you go back and you start and you kind of just do it again. That's 233 and it's going to go to, what's that, 336. 336, that's here. And then I'll go back here and fix that. And you just pretty much keep going. Let's try the next one. 336, and I'm going to go to 439. 336 to 439. Okay. Can you, oops, one of them's not right. Let me fix that. It's, darn it, in space, it should be 339. It shouldn't be 439. And it should be going to 542. Somehow or other, I missed one. Okay, there we go. So I missed this guy in the middle. That's easy to do. Pick that dot, finish that dot there, got that one. Can you imagine I just went through the entire table and joined them dot to dot, dot to dot, dot to dot. The trick to getting them in the right place is to hit the segment and write down the real coordinates based on these ones. So the last one I would do would be 952 and 1054. So if you go to 9 and you do 52, it's about here. And you finish at 1054, which is about here. And if I look at that line segment, oh, guess what? I'm getting better at it. That's actually in the right place. Does that make sense how you go through that process? And when you're finished, you'll just have a diagram made up of a whole load of dots joined together by little pieces of lines, little line segments.
Yeah, that part makes sense to me. It's just not accepting the answer.
Yeah, I've had other people say that. I don't think that is an issue with what you're doing. I think that's an issue with WebAssign not being very good at knowing when someone's drawn the correct diagram.
For the ogive, you also need like an extra point too. So
Well, you need
Right.
0.5 comma 0, yeah, for the ogive. But
Yeah.
I've had people who did that right, and I went and looked at the work and it looked right in WebAssign.
Right. I was one
I
of those
can't help you with that. So let me phrase it this way. You're correct whether WebAssign says you're wrong or not. And what you do is you shoot me an email and I'll go and double check. And if I agree that you're actually correct, I just go and I add the points and you're good to go. Now that won't be an issue in the test, because in the test, I obviously will go and look anyway, and I will be able to check as a human being can check that the diagram's actually correct. So it's idiosyncrasy that WebAssign, for some reason, seems to have a really hard issue with getting the graphs right. And it's not a major one, because some people haven't gotten to me, so I'm assuming it worked fine. You know, they got the answer. But for whatever reason, it doesn't always seem to work for everyone. I think one of the problems might be is, you might not know this, but WebAssign generates unique data sets very often. So if you went and looked at someone else's data set, it wouldn't be the same numbers. So maybe that's part of the issue, that you just got an unlucky data set and WebAssign couldn't handle it. It's as good an excuse as any.
Well, I will email you then, and you can
Right, and I will have a
grade my
look.
homework.
Well, I only need to grade the graphs. And WebAssign's pretty good when the answer's 42, right? It'll tell you you're right and we're okay. So it's not a biggie. It's easy to check. I can look at this and it's pretty easy to check if it's right. Can you see the dots just nose to tail all the way? Let me do a wrong one. If I saw part of your diagram look like this, I would know that was wrong just looking at it. Agreed.
Right.
You wouldn't have a dot floating in midair like that. So it's easy to check. Does that mean that you were doing the ogives right and it just wasn't telling you were right? Or do you want to see an ogive curve now?
No, I mean, the issue that I'm having is not that I don't know how to do the work. It's that WebAssign is
not very good at knowing that you're doing it right.
Yeah. So
I wish I could help you. You're good then. If you're good.
Yep.
Right. Is there anything else in the charts world that you want me to talk about before we kind of start the lesson?
No, I'm just going to have you look at it later. Privately.
Okay, I can do that.
So that's fine.
So if you're good right now, you can disappear and get on with your homework or do what you need to do. And we will start the lesson from the beginning. Okay, let's have a look at, in no particular order, let's look at how you can do diagrams and charts for non-numeric data. So I'm going to go out for a second. And I'm just going to mute everybody. That might stop some of my distracting noises. There we go. Okay, non-numeric. It's just a fancy way of saying the data isn't numbers. And there are two versions of this. So this is kind of a revision in a way. Sometimes it's nominal. Does anybody know what the other one's called? Just as a question. Hit the space bar now because I've muted you all. What's the other one called?
Ordinal.
Yeah. And we are going to look at how you do charts, how do you do pictures, and how do you do tables using this information. And the good news is, for the most part, it's pretty straightforward, and you've probably seen it before, but we're covering it just for completeness sake. So let me tell you what the difference is. I like the word ordinal because it makes me think the word order. So ordinal data is data that is not numbers, but it still has a natural order. So for instance, if you were asking, if you collected data on students at high school and you were just finding out, are you a junior, are you a senior, are you a sophomore, are you a freshman, right? So what your answer would be, you know, 42 are freshmen and 39 are seniors and so on, right? That data would be considered ordinal because there's a natural order, isn't there? You know, finishing junior, senior. If you were collecting information about what rank you were in the military, can you imagine some people are privates, some are sergeants, some are generals? In that case, isn't there a natural order? You know, private is the lowest, the first one, and then, you know, general at the end. So if the data has some kind of order, then it is ordinal. So as example, junior and senior and so on. Nominal is data that has no natural order. I like things like color. So how do you set up tables to organize these? Well, this is how you might do a table for nominal data. So let's have color. And you collect a sample and you find some kids and you get them to tell you their favorite colors. And your table might look something like this. Red, blue, green, pink. And you have a column called frequency. And 7 liked red, 3 liked blue, for whatever reason, 10 liked green, and only 2 liked pink. And that is basically a frequency table where you just count each of the colors, right? So you imagine you've collected all this data, and this particular data was 22 kids. So can you imagine there were 22 kids in kindergarten, and the ones that could talk, right? And you got them to pick a color, and this is what we got. Now, if you want to take this table and you want to create a diagram of it, the diagram that you're likely to make is called a bar chart. So what does the bar chart look like? Well, you probably did it when you were 10 or even younger. Along the bottom, you put, in this case, color, and then choose a scale. And you do frequency on the scale. And what you're doing is you're basically taking this data and trying to visualize it in form of rectangles. So 7 of you liked red, so you go here and you go up there and you tell everybody it's red. Then you leave a little space and then you do blue, but there's only 3 of them. You do a little space and you go all the way up to 10. Go back down, and that would be green. You do a little space and you go 2, and you get pink. Would you agree that's a pretty basic diagram? You could have done that when you were 6 or 10 or something. Pretty straightforward. And we call that a bar chart. Now, there is another version of this chart. It's called a parental chart. And what you do is you take the exact same data, but you do an order. Now, I know I said there's no natural order, which there isn't. But in a parental chart, you put the biggest one first and you work your way down. So what that means is you start with green, and there's 10 of them. I'm just going to call it G this time. The next one would be red, you leave a little gap. You do that guy, call that red. Next color is going to be blue, and there's 3 of them. And last, you get pink. There's 2 of them. So this is nominal data. Would you agree that this chart and that chart has exactly the same information on it? Right? It's not like they're telling you different things. This one is just a random way that the colors came out. This one, you put them in order from biggest to smallest. And when you do a bar chart, because a parental chart is just a special bar chart, you do it like that. So when you get a homework question and it gives you some data and it says, which one of these 4 pictures is the correct parental chart? So at least they don't get you to have to draw on the software these, because that would probably be a real pain based on the problems that we already seen with the dots. You would just pick this picture here as the correct one for a parental chart. So far, so good. Bar chart, any old order, whatever the table says. Parental chart, put them in order from biggest, most popular to least. Now over here, there's 1 extra column, and it's called relative frequency. And relative frequency, you take the number, and you divide it by the total. And in this case, 7 divided by 22, and that's about 0.32 to 2 decimal places. And then you take the next one, and you write down 0.14, take the next one, and you get 0.46. You got the last one, and you put 0.09. So this is a relative frequency, which is sometimes asked in these questions. Down a little bit. Any questions so far, or does this make sense? I'm having my little camera. It's not where I want it to be. I must have knocked it in some way. There, I think I finally got it in the right place. Are we cool with these guys? Does it seem reasonable that if I gave you data like this, you could create one of these pictures? And if I gave you this data, you could do that? Yes.
When I did the relative frequency and it asked to round 4 decimals,
Yeah.
I don't know if I'm just like missing something, but it kept marking them wrong. I don't know
Okay.
if I'm rounding up wrong or.
Well, let's just practice one and show you what happens. So suppose I was doing the 7 to 4 decimal places. The answer, I'm writing down all the digits, that way I can write on something, right? Oh, it's one of those guys, right? Goes like that. Right. You go to the 4th decimal place, which in this case is 1. And then whatever the next digit after it is the rounding off. And the rule is, if this digit is 5 or more, you round up. So that's it. There isn't an issue. What could have gone wrong? Will you make sure that that's the right number? I mean, I guess you could misread that, but make sure you're dividing by the total. Was this a question where you got the table and then you're filling this in? I'm trying to think of what the question might look like.
Yeah, sorry, my computer keeps freezing, but yeah.
So you had these numbers here told to you, and you were just simply being asked to get the relative frequency.
Yeah, I think I was just trying to round too many numbers or something like that.
So it was just a rounding off issue. So
yeah,
easy fix, right? You get 3 shots, so hopefully you've still got another shot or 2 left to fix it.
Mm-hmm. Thank you.
Okay, now, suppose you wanted to take this data but use relative frequency instead of frequency. Whether it's a parental chart version or just a bar chart version, it would be the exact same process. I just don't want to do the whole process. So can you imagine you just change the scale to be 0.1, 2, 3, 4, 5, 6, 7, 8, 9, and then you just do the first one 0.32, and the next one 0.14, and the next one 0.46. It would look exactly like this. Whether you use a relative frequency or whether you use a frequency, the relative heights will stay the same, right? If it's big in one, it's big on the other. If it's twice as tall in one, it will be twice as tall in the other. And that's pretty much how you would deal with nominal. So how do you deal with ordinal? Exactly the same way. If the data has a natural order to it, you should do a bar chart. So can you imagine I did some data and it was ordinal. You'd think by now I'd remember, but I just don't have a good memory. So here goes. Suppose we are talking about some high school students and we just collected a random sample of them. 1, 2, 3, I need one more, okay. I know you finished with senior, and I know the one just before that is junior. Is it freshman, sophomore, or sophomore, freshman? I can never quite remember. Freshman first?
Freshman's first.
Okay.
Yeah.
Can I just do FR for freshman and SO for sophomore, because I'm getting tired of writing all these words. And you collected data. Maybe it's in the chess club, and you find out that there's 5 in this, there's 10 in this, there's 3 in this, and there's 1 in this, right? So this is your frequency. So what would that look like? Well, if you did a bar graph, you would simply start here, go here, put in freshman, and it would go 1, 2, 3, 4, 5 tall. Leave a little space. 5 is there, isn't it? Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's your sophomores. There would be your juniors. And there's 1 senior. Put a little scale on it. Put headings. I don't know what to call this position, I guess. And you have now done a bar chart. Now, when you look at this, can you see there is a natural order from freshman down to senior? And can you also see that it's, in this particular case, there's more sophomores than anybody else? Yeah, you can pick up things like that. Now, if you wanted to do a relative frequency of this, this particular one adds up to a total of 19. So let's use that one as practice at rounding off. Let's suppose 3 decimal places this time, right? Because that's what they asked for. You would take 5, you divide it by 19. Well, you want to make it on first. 5 divided by 19. And it's either 0.263 or it's 0.264, right? You either round down or up. The next digit after the 3 is a 1. But what about that 5? That 5 doesn't matter. You only look at that digit. The rest don't matter. Pretend they're not even there. So this one is 0.263. And then you just do the rest. If I was going to take this same data and do a parental, and you're going to get the really quick version of this. Do you see that I would just rearrange the order in which I did my rectangles? So this is a bar graph. This is a parental chart. Are we good? There's not an awful lot of questions you can be asked in these, but I guess the obvious ones are, In the chess club, which group had the most? You would say there were more sophomores in the chess group than anybody else. Which one had the least? Fewer seniors than the rest. In the colour one that I did a minute ago, couldn't you say what's the most popular colour for kids at kindergarten? You know, what colour do they like the most? What colour do they like the least? That's about it, really. So the last one of non-numerical data is called a pie chart. I think they call it a circle something in the homework. Can anybody remember what it was called? It was a circle something. What on earth do they call it? I mean, it is a circle, I know that, but what do they call it? There we go. It's called a circle graph. Okay. So how do we get, or how do you create one of these? Well, thankfully, there's only one question. So I tell you what, I'm going to use this data so I don't have to reduplicate everything. So imagine I'm going to do a circle graph using the kids in the kindergarten. Well, you add another column. And in this column, you're going to put the number of degrees that you need, because there's going to be a big circle here. You start there and you go like this. Right. The relative frequency of red was 0.32. So if you're looking at red, it's 0.32. Or if you like, 32%, which is the same thing. So the angle that you use, right, how much of this circle is going to be used up by the red? The answer is 32% of 360 degrees, because an entire circle is 360. So I'm going 0.32 times 360, and I'm coming up with about 115.2 degrees. Can you imagine you had one of these little guys called a protractor? The good news is you don't need one for the one question, but wouldn't you place the protractor on that and then you'd measure off? And can you pretend I'm really good at guessing? That angle there would be 115.2 degrees, and you would write down red 115.2 degrees. And then you'd move on to blue. And in blue, it's going to be 14% of 360. And 0.14 times 360, that's 50.4 degrees. And can you imagine I did that, and that angle in there was 50.4. You write down blue and 50.4 degrees, and then you do green, maybe that, and then you finish with pink. Now, there is only one question where that in the homework even comes up. So I'm going to show you that question and hopefully make your life a lot easier by just doing it with you. So here we have data on 5 rivers in Ireland and how many spearheads were found. And below you can see 4 charts. Here is the data. One of these 4 charts is going to be the parental chart. Now, because they've given you a choice, couldn't you just use their choices without physically needing to draw it? So let's see what that would look like. Based on this data, shouldn't the biggest rectangle be Shannon and it should be 34 high? Right, if I scan through these, can you see Shannon 34 high? Won't this guy be the one you're looking for? So that's how quick it is to basically, if they give you 4 pictures, can't you just pretend I'm just going to do the first rectangle? And if you get that right, you kind of know what the rest would be. Now, this is the circle guy. Now, do you notice in every single one of them, let's use Shannon. Okay, well, I'm writing this down. Shannon has got 34, and the total number, if you add them all up, is 20, let's see, 4, 8, 13, 17, 27, 37, 47, is 77. So this is how I probably would have done this question if it was me. I'd say, okay, 34 out of 77. 34 divided by 77 is about 0.4416. And that's 44.16% if you like percentages. And just times it with 360. And I get 100, well, oh. I can't count. I apologize. Let me do it again. 23, 33, 38, 68, 72, 82, 86. Let's treble check that. The data that I'm making a big meal of is just adding these guys up. And then I'm going to take Shannon, which is 34, and divide by this total. 13, 18, 19, 20, 26, 2, 3, 4, 5, 6, 7, 8. That guy, 34 divided by 86 is 0.395, which is about 39.5%. Okay. Let's go back and see which picture that guy is. There we go. Do you see his picture too? So that's how you would have physically done it, but in the case of these homework questions, they take a kind of shortcut way of asking it. That would be the shortcut way of answering it then. And that is us finished with what you can do with non-numeric data. Bar charts and parentos and circles. So we're now going back to numeric data to finish today. And we'll look at time graphs, also called time charts. And we're going to look at stem and leaf as well. Okay, suppose you had data and you had time and you had position. So at time 0, at time 1 second, at time 2 seconds, at time 3 seconds, at time 4 and 5. So you were doing this little
screen.
Let's get that fixed.
Thank you.
So this, imagine you were doing something in physics and you were measuring where an object was, right? And you had a little stopwatch or you had a camera, whatever way you did it. And at the beginning, it was at position 7, and then it went to 9, then it went to 10, then it went to 8, then it went to 6, and then it went to 2. This data basically only has 2 things: the time at what the thing happened and its position. And if you want to make one of these graphs. The horizontal axes will be time. In this case, 0, 1, 2, 3, 4, 5. And the vertical scale will be whatever it happens to be. In this case, it's position. And we need to get up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the way you create it's a little bit different, but not much. At 0, it's 7, put a dot. At 1, it's 9, put a dot. At 2, it's 10, put a dot. 3, it's at 8. 4, it's at 6. And finally 5, it's at 2. And then you join them up like this. Remember when I was on the screen at the beginning of today, didn't you plot these dots with that funny little start dot, finish dot, and then you had to go in and check that you got the right position? That's going to be the pain in the butt thing, right? It's not drawing it. Actually, drawing it by hand was really easy. Drawing it on WebAssign is going to be more of an issue because it's clunky, right? The way they get you to do it in the software is maybe not the most intuitive. Do you want me to go back and show you how I did that again? Or can you remember how I did it when we did it at the start? I'm home, either way. What do you want? We good? Yeah, we're good, okay. So, when you do these questions, some people, not everyone, I don't know why, it's WebAssign being weird, will do it and it will give you a check mark and you're happy and you move on. And sometimes you'll do it right and it will tell you you're wrong. And you're just going to send me an email saying, look, I'm 99% sure I'm right. I'll look at it and I'll just give you the homework point for it. And you don't need to get frustrated by, I can't make WebAssign say correct, because it probably never will. If it's got some kind of bug in it that makes graph reading difficult, we're going to have to just live with it. Do the right answer. If you're sure it's the right answer, shoot it to me and I'll check it and I can give you the point. I'll just override WebAssign and you'll get the marks. Are we good with time graphs, time charts? Now, what can they ask you? Well, I mean, if you look at this chart, can't they ask you things like, is there a trend? Well, in this case, doesn't it go up the way and then it goes down the way? So it might say, when was this moving object increasing? Well, wasn't it increasing in the first 2 seconds, right? It was going uphill. When is it decreasing? Would you agree it's decreasing for the other 3? When was it at furthest away? Furthest away at the 2 second mark. And that's about all I can think that you could be asked. You ready for the next one? Stem and leaf. When I finish doing this question, there are going to be 2 versions of this. There's going to be the first version is where there's only 1 row in each stem, and the next time it's going to have 2 rows. And we'll show you how that would look. So how many people have we got? Have we got enough people to actually use you lot to get data? No, we don't have enough people. Okay, so I'm just going to pretend that I collected some data, and it was students, and it was 17, 18, 18, 19, 25, 27, 29, 31, 38, 42, 63. Don't need any more. Yeah, that'll do. So here is a very small set of data, and we are going to create what's called a stem and leaf. So a stem and leaf, you start with 2 vertical lines like this. In this case, the data starts at 17 and finishes at 63. So what I'm going to do is I'm going to put in 1, 2, 3, 4, 5, and finally 6. This is called the stem. That's the name we give to this thing here. It's called the stem. And if you're lucky, the data will be in order, but it's probably not. In general, it's going to be all jumbled up. So what we have here is 17, 18, 18, and 19. And then we go 25, 27, 29. Then we go 31 and 38. Then we go 42, and finally we go 63. Do you see that basically I don't write the whole thing down? Don't I just write the units part of the thing? And these guys here, these are called the leaves. So that's why it's called a stem and leaf. And you need basically a key. And what you say in the key is you pick one of them at random, it doesn't matter who, that one, and you write down what that means. In this case, it means 38 years old. Now, the reason you need that key is that you can do a stem and leaf with data where these numbers could mean different things. Can you imagine that this data was actually 1.7 and 3.8 and 6.3? It would still look like that, but the key would say 3/8 means 3.8. And can you imagine this data was 170 and 420, you know, numbers like that? Then wouldn't 3/8 mean 380? So the key is important to the understanding of what that data is. And I like stem and leaves. They tend to be pretty quick. Would you agree that they don't take too long typically to do? And you can do this with stem and leaves. See, if you turn them on their side, don't they look like little histograms? I kind of like that. So imagine that I had a stem and leaf where the data was all jumbled up. And it might look something like this when I'm finished. That isn't the final result. A stem and leaf is built that way, but these are not in order. So what you would need to do here is fix the stem and leaf. So you might do that on a piece of paper because the data is all jumbled up. So, you know, by that I mean you get a 17 and then next door to it, there's a 47 and then it's a 21, then it's a 29, right? So you go through the stem and leaf like this, but once you've got it, you then go back and it doesn't take a lot of extra work. And this is the final result. You see it's now in order. It's not considered a true stem and leaf when it's mixed. It's now considered to be in its proper form. And this is a version of the stem and leaf where each stem just has one row. By that I mean two just has one things. So what does this 2-row thing that they talk about, right? A stem and leaf with 2 rows per stem. I wonder, imagine I got some data and it looked like this. And I'm putting them in order to make my life easy. And I wanted to make a stem and leaf of this data. I could do 1, 2, 3, 4, right? And it would end up looking very similar to this. Agreed? But when you are being asked to do 2 rows, there's a refinement that you take. You have 2 1s. You have 2 2s. You have 2 3s. And you have 2 4s. That's it, that table's finished. That's why it's called 2 rows per stem. Do you see that there's 2 1s, 2 2s, 2 3s, and 2 4s? Now you might think, well, how's that going to work? In the first row, only numbers that look like that. And in the second half, only numbers 5 and bigger. So, 17, oops, keep it in red, 17 goes here, 18 goes here, 19 goes here. Because aren't they 5 and bigger? Right, the next one, 21 goes here, 23 goes here, but 25, 27, and 29 go here. 31 and 31 go here, nothing in that row, nothing in the first 40, and 45 goes here. Do you see how I created this data using 2 1s, 2 2s, 2 3s, and 2 4s?
Does it always go to that scale?
Say again?
Is it always to that specific scale? 4 always goes in the lower one and 5 always goes to the upper one?
Yes, always that scale.
All right.
So 0, 1, 2, 3, 4 goes in the first one, 5, 6, 7, 8, 9 goes in the second one. Do you see you're basically giving each one half the data?
Yeah.
And that's the reason that you always split it that way. To be complete on this question, and you got to tell people what it means, right? Do you feel comfortable about how you would create a stem and leaf from raw data, where it's 1 row per stem, or if it was 2 rows per stem? You feel good about that? Right. That's going to be our last thing. So I am going to go and pick a question in the homework that's kind of like that, and then we can, if I can find one, and we can look at the stem and leaf creation. Oh, are you looking at, or you should be looking at, let's check it out. Are you looking at the homework questions on the screen in front of you? You great? Right. Do you see this guy? You're going to do a time series, right? Can you see that you don't physically, well, you do physically do it, but don't you just pick the right picture? So that question, I don't know what the right one is off the top of my head, but I can have a guess at it. I need 3, 8, 17, so it starts and finishes. I'm pretty sure it's that one, but you can double check yourself. Right. Let's look at a stem and leaf question 10. And I'll make this a bit bigger now, because I know some of your screens are not that large. Right, as you scan through this data, it's talking about how long did real cowboys live for. And we're talking about, you know, cowboys in the, you know, John Wayne, not John Wayne, but you know what I'm talking about, right? In the 1800s, right? With gunfights and all that good stuff. So here is the ages of a sample of real cowboys and how long they actually lived for. And we're going to do a stem and leaf for it. So these guys here on the left are going to be the stem, and these guys here on the right, they're going to be the leaf part. So as you scan through this, would you agree? I'm checking because my scan is horrible. Is 50 something the smallest number that's in that table?
47.
Thank you. So I missed it. There's a 47. So you go 4, 5. Now I'm not going to do this whole question, but just, oh, yeah. 4, 5, 6, 7. I just got distracted for a moment. I was wondering if they wanted 2 leaves or not, but they want 1. If they don't mention, it's always 1. Right, now, You said there was a 47, I think you said? Yeah, right at the end, I can see it now. Starting at the beginning, 58, 92, and 85. I'll do one more column. 52, 66, and 84. Do you notice that I just move the numbers in order as I come across them? For me, if I do them one column at a time, I'm less likely to screw up. So when I'm finished, can you imagine this whole thing's going to be populated with various cowboy ages, right? Now, I wish I had the time, but I don't. So I'm just going to make up numbers here. Right, can we pretend that's what that data looked like, right? Now, what that allows us to do is then, if this was the right data, couldn't we go in here and look at that data and answer this question? According to a guy called Baron von Richthofen, which I'm assuming is the same Baron von Richthofen that was the World War I flying ace, you know the guy I'm talking about? I'm assuming. How many barons are there in the world? And he went there and he went and said that cowboys are found among the sons of the best families. The truth is probably that most of them weren't drunks and gambled a lot and shot each other, right? Which is what movies are, right? If you think of a movie, don't cowboys get shot a lot in gunfights and drink too much and so on? Well, evidently, he says that's not true. Now, if you look at this data, if this was really true data, don't cowboys typically live for a very long time? Look at the kind of ages that they died at, a 92 and a 94. Well, I know for sure wasn't there at least one 92. That's real, isn't it? And there's a lot of 70s. Can you see there's a 77 there, there's a 73 here, and there's a whole bunch of 70s. So wouldn't this be strong evidence that cowboys actually did last a really long time? In fact, looking at that data, do you know, it wouldn't surprise me if people out in the open plains, the cowboys, lived longer than people who lived in New York in the slums in the 1820s. Can you imagine what New York in 1820s might look like with the dirt and disease? Wouldn't you probably live a lot longer out in the open air with good food and lots of meat? So, yeah. So one of these three would be right, so it might be yes. Now, the next and last one we're going to do is one where it says not one digit as a leaf, but two. So there should be an example of that somewhere. And that's not one. Here we get one. I'm going to make a stem and leaf of this data here using 2 lines per stem. Okay. So if I scan this data here, which is about how many shots people in the open golf tournament took to finish the course, I believe the smallest number is 60 something and the largest number is 70 something. So 60, 60, oops, try that again. 2 60s and 2 7s. And 71 would go in that position. So would 70. 66, would it go in the top one or the one underneath it? Where would I put 66?
The one underneath.
Yeah. And can you imagine filling in the data and calling it good? Right now, some people have told me, well, one person has told me that they did this right and it didn't work. And in other words, the software said you were wrong, even although she's sure she put the right data in. So there is two possibilities here. So I'm going to tell you both, one of which I know is correct, but I don't know which one WebAssign is. WebAssign might do this, that you need to put commas between your digits. And if you don't have commas, it will say you're wrong. Or WebAssign will say, don't use commas. And if you did, it would say you were wrong. So I guess you've got two choices here. Does it use commas or does it not? And actually, I can cheat by doing it. I get to the top here. I think I can ask it to put the answer in. Okay. And the answer is, you don't use commas.